Now I'm going to present a topic matrix multiplication from unit 3 of parallel algorithms. What is matrix multiplication? To design an algorithm to multiply two matrices of arrays n cross n using a n square processor such that matrices A has elements Aij and matrix B has elements Bij respectively. The processing element Pij represents Aij and Pij. First, you have to arrange the matrices A and B in such a way that every processor has a pair of elements to multiply. The elements of matrix A will move in left direction and the elements of B will move in upward direction. These changes in the position of elements in matrix A and B present each processing element P a new pair of values to be multiplied. This normal serial algorithm for this matrix multiplication is outer loops I and J. It represents the values of A and B, and the inner loop it does the multiplication operations. How this multiplication operations performed here is, that is I k of the array matrix A and K and J elements of this matrix B is multiplied and it is added to the C. C is a resultant matrix. This operation will happen serially, whose running time for this serial algorithm is order of n cube. N is nothing but a total number of elements, or that n is nothing but a matrix dimensions, that is n cross n. The parallel algorithm here is, will be given a matrix. It is divided into a block such that matrix A is divided into a 9 blocks and B is divided into a 9 blocks. So let us take the first block of A from the matrix A and the first block of this matrix B from the matrix B, which is called as a C of 0, 0. Similarly, we take the remaining blocks, that is second element of this A matrix and the second element of B matrix, which is called as C of 0, 1. Totally there are 9 blocks and the last block is, that is C of 2, 2, which is nothing but elements from the 9th element of A and 9th element of B matrix, which is to be multiplied. Whose pseudo code here is given that first all the processing element of Pij, where I ranges from 1 to n, if I is greater than n, then we can rotate the matrix in left direction. Suppose if j is greater than n, then we have to rotate the matrix B in upward direction. Initially it is said that by moving the matrix in the A matrix in leftward direction and moving the matrix B in upward direction, multiplication is carried out here. For all the processing elements Pij, it lies between 1 and 2. You have to compute the product of A and B and it is stored in C. So each time we have to rotate A in left direction and we have to rotate B in upward direction, and we get the result as C equal to C plus A into B. The steps can be, says that partition the A and B matrix into P square blocks. Okay, so P is the number of processor available. So based on the number of processor, we have to divide the matrix elements into P blocks. For example, if there are 3 cross 3 mesh network is available, then we have to divide the matrix into 3 cross 3 blocks. Ensure each process can maintain a block of A and B by creating a matrix of process size P1 by 2 and P1 by 2. Provided each block of the matrix is assigned to the processor. The blocks are multiplied together and the results are added to the partial results in the C sub blocks. After dividing the matrix and assigned to the processor, it is multiplied and it is assigned to the C sub blocks. The subblocks of A are shifted one step to the right and the subblocks of B are shifted one to the step up. So we have to repeat the process for P1 by 2 times. So once the nth rotation is completed, we get the final multiplication of the matrices. The running complexity of this algorithm is it takes order of n. N is nothing but a dimension of the matrices. Say for example, let us take a 4 cross 4 matrix which is divided into a blocks, that is 4 square blocks, that is P00, P01 and P10, P11, whose initial element are like this: 2107 and then 47272. Where we have to rotate the A matrix by left and B matrix by, that is, up. So after rotations, then we do the multiplication, that is C0, first block of first multiplication, that is C00, that is first block of C, and then second block of C, and then second row of the first element of C, second row and second column of the C. So after multiplication, we get the final results. So that's all about this matrix multiplication.